Hey everyone, I'm doing a problem in my book University Physics, and it's a problem on page 91, problem 2.71, and it has a difficulty level of 3, so maximum difficulty, and it requires some calculus. Let me read it, and I'll register information as I read. The acceleration of a particle is given by this equation. AX as a function of time equals minus 2 meter per second squared plus 3 meter per second cubed multiplied by t. And you're asked to find the initial velocity v naught of x such that the particle will have the same x coordinate at time equals 4 seconds as it had at time equals 0. So basically, the speed required such that x of 4 equals x of 0, from what I understand. Okay. The second request, what will be the velocity at time 4 seconds? Okay. All right. So let me think. I have an equation and I can use derivation to find the velocity version of this equation. So I can say that the horizontal displacement of this particle as a function of time, actually it's not the derivative of acceleration, it's the integral of the acceleration. And it goes like this. The acceleration is a function of time multiplied by dt. This will give us negative 2 meter per second squared multiplied by time plus 3 meter per second cubed over 2 multiplied by t squared. Also the constant, which will be Vx naught, Vx time 0. So that is my equation for velocity. I also need to work out the equation for, let me actually write that this is the velocity equation, or the velocity function. In order to compare the x coordinates, I also need the position function, which could be found. So position as a function of time equals the integral of Vx like that, and you would have -2 meter per second squared over 2 t squared plus three meter per second cubed over 2 over 3 and t cubed plus v naught x t plus initial position, which is the constant. Now I can simplify this a little bit. So 2 over 2 is just 1. So I'll say negative meter per second squared multiplied, hold on, -1 meter per second squared multiplied by t squared plus half meter per second cubed multiplied by t cubed plus v naught x t plus x naught. Okay, where did I get this half in the second term? It's, 3 divided by 3, that's 1. 1 over 2 is half. And I'm keeping 3 significant figures for each measurement. Hold on, I'll have my lunch and come back. Alright, I'm sorry, I'm back. I was having lunch. So, where were we? We were trying to find the velocity, or the initial velocity, of which x will have the same value at times 0 and 4 seconds. So let's actually make an equation. Let me first label this equation as the position function. It's a function of time. And let's equate these two positions. So the position when time is 0 equals the position when time is 4 seconds. And I want to expand both sides. So I'll write the equation. When the time is 0, this is multiplied by 0. This is 0 squared, this is 0 cubed. We know these terms will terminate. Okay. And the other side would be like, if I start from here, if you guys don't mind, 4 seconds squared plus 4 seconds cubed plus initial velocity multiplied by 4 seconds plus initial position. So this term is 0, this term is 0, this term is 0. And essentially, you have a situation like this, where on the left side of the equation, you only have the initial velocity, the initial position. On the other side, you have also a term like that. So let's actually write it in full, just to show what I'm talking about. So this is the right side of the equation, where I substituted 4 seconds in place of the symbol t for time. This is t cubed here, so 4 seconds cubed. V naught x, and 4 seconds plus x naught. So if you notice, on both sides we have this term, so you can just subtract x naught from both sides and rearrange the equation so that you solve for v initial. So you'll have the v initial of x equals -1 meter per second squared. This is a fraction, right? So I'm writing the numerator first. And if I square the time already, I'll have this as the first term. Second term is like this, and 4 cubed is 64. So 64.0 second cubed. And the third term is part of v naught, so I'm going to divide by that term for seconds. And you notice that the seconds cancel from the upper part of the fraction. And as you continue to solve, you'll have -16 meters above plus 32 meters. They're divided by 4 seconds. It seems like we're getting a very nice even number. So the upper part is 16 meters and the denominator is 4 seconds. Therefore, the initial velocity x equals 4 meter per second. Okay, so the initial velocity such that x of 4 seconds equals to x naught. Okay, part B of the question asks for the velocity at time 4 seconds. So let me know the constant, which will be paste here. Yeah, said we dubbed this equation as the velocity function. Function of time. Part B of the question asks for Vx when the time is 4 seconds. And this is easy. You just substitute 4 seconds in place of the time. So you'll have -2 meter per second squared multiplied by 4 seconds. And in the other term, you have 1.5 meter per second cubed multiplied by 4 squared. So that's 16 seconds squared. And at the end, you have the initial velocity, which we solved in the earlier part of the question. It is 4 meters per second. The first term, you'll have 4 multiplied by 2. It's actually a -8. But you have the seconds. The second square going into a second. So you'll have meter per second, first term. Second term is 1.5 16. That is 20. 20 meter per second. And lastly, you have 4 meter per second. And you just add now 24 minus 8, that's 16 meter per second. The velocity when time equals 4 seconds. Okay, so whatever direction the particle was moving in, let's say initially it was moving like this, with a initial position and let's say a velocity, initial velocity of 4 meters per second. Whatever direction this side is, let's just say forward. So after 4 seconds, it is still moving towards that direction, because forward takes a positive value. Therefore, our answer was positive as well. So the particle is moving there, same direction. All right, that is it. It was a little bit long. Thank you for watching.